In the series of videos of transaction management, first we are gonna learn what is transaction. A transaction is nothing but a collection of operations that form a single logical unit of work are called transactions. There are many operations performed on various data items, and the collection of those operations are known as transaction. The example of transactions is this. This is a transaction which is performing read on data item A, then subtracting 50, then performing a write operation, performing a read operation on B, and then writing B. But this is not complete transaction because it is not ending with a commit or an abort. If a transaction is not having a commit or abort, then it is called partial transaction. So it is a partial transaction which is not having any commit or abort operations. So these transactions have ACID properties. From ACID, A stands for atomicity. Either all operations of the transaction are reflected properly in the database or none are. This means that all operations in the transactions are performed or none are performed. It is not possible that initially some operations are performed and the transaction failed and some values are updated and some are not updated. That's not the case. If that's the case, then it is not following the atomicity property. Atomicity is either all operations of the transaction are reflected properly in the database or none are. Second property is consistency. By consistency, we mean that execution of transaction in isolation, that is with no other transaction executing currently. Isolation is like only one transaction is performing operation on one data object. Due to isolation, this preserves the consistency of the database. Also, by consistency, we can say that suppose a bank transaction is taking place in which some person is transferring some amount to other person. Suppose A is transferring $100 to B, then if there is no consistency, then the sum of both the bank balances will not be equal, but it should be equal after the transaction ends. So this is consistency, maintaining the database properties before and after the transaction. So this was an example of consistency, but isolation is taking place, which is our next property. Isolation is nothing but when multiple transactions may execute concurrently. The system guarantees that for every pair of transaction Ti and Tj, if Ti and Tj are two transactions which are operating on the same data object, then both will be executing concurrently but in isolation. It's not possible that both can execute the same data item at the same time. So if transaction Ti and Tj, it appears at Ti that either Tj finished execution before Ti started or Tj started execution after Ti finished. Thus each transaction is unaware of other transaction executing concurrently. Both transactions will not know that some other transaction is also happening, but they can happen concurrently but with isolation. And the last property is durability. Durability, as the name suggests, means that in any case, if the transaction fails, if transaction does not fail, in any case, the properties of database remains same. The definition is after the transaction completes successfully, the changes it has made to the database persist even if there is a system failure. In any case, database properties should be maintained and they should be consistent. In any natural hazard or any logical hazard, the values of the database or the properties of the database, we can say, must not change. So these were the four properties which are known as ACID properties. So we'll move on to the next video. These were the basics.